Kia ora Year 12. I'm going to give you out a worksheet from Mr. Hurring that's got lots and lots of different graphs on them, and they're all red and blue. And then I'm going to do videos to go with each section. I'm going to keep the videos to one kind of graph per section, so this is the one on trig graphs. So in that worksheet, you've got 6 trig graphs. Here are the first 2, here are the second 2, and here are the third 2. And you have to work out the features of the graph and also the equation. So what I want to look at is how do we do that, and what do we start off by choosing? Well, your big question when you've got a function that looks like a wave is, do I want to model it with a sine curve or a cosine curve? So let's go all the way back to our basic patterns. The sine curve starts at the origin. This is the very basic sine curve, right? And we're going to transform that and do stuff to it. But if your curve has a pattern where you can see a starting point in the middle at the origin, then a sine curve is probably going to be the easiest way to go, right? Notice that it's not just at the origin, but it's the bit of the curve where I'm at the origin and I'm going up, right? We'll see one soon where I'm actually back here, but that's your basic sine curve pattern. Okay, so let's take that off, and now remember what the cosine curve looks like. Well, the cosine curve starts up here as if we're at 1, so it's more like the top of the roller coaster. Now, it should be pretty obvious that I can get from a sine curve to a cosine curve by shifting one of them along. And all the way back a few weeks ago, where we had the lesson looking at the unit circle, we looked at why that was, right? But for now, all we're trying to do today is to figure out how to write the equation from looking at a graph. Okay, so let's start off by deciding in each of these cases, are we going to use a sine curve or are we going to use a cosine curve? Well, let's look at the blue one first. Well, you can see the blue one starts at the origin and is going up. So it makes sense to use a sine curve for this one. Now look at the red one, and it's the same kind of thing. Obviously, it's been shifted up somehow. We'll get to that. But you can see the starting point is here and I'm going up. So I'm going to use a sine curve for both of those, because that way I won't have to worry about any kind of horizontal shift. So let's now start with looking at the blue curve and remember, what is my basic form of sine curve? Well, I've got y is equal to a sine b x plus c plus d. So what are all these things and where is a good place to start? Well, the d is the vertical shift. And the A is the amplitude. Now, I always start by finding the vertical shift and from there finding the amplitude. So let's see if there's been any vertical shift. And sometimes it'll be really obvious that there hasn't been. Looking at the blue curve, where does it go from and to? Well, the blue curve is symmetric around 0, right? It goes from -3 up to 3 with the y values. So -3 plus 3 are the top and bottom limits here. Halfway in between gives me 0. Now, I didn't need to really even do that for this one because it's pretty obvious that that curve has not been shifted, right? But this method here of taking the high and the low values and averaging them is going to work quite well in other cases. So here we know that there's no vertical shift. So d is equal to 0. What about the amplitude? Well, my middle value of y is at 0 and I go up as far as 3. So the amplitude here is going to be 3. We can see that we've got no horizontal shift here, right? We've already looked at why that is. We've got a starting point that is happily for us sitting right on the origin, right? So that means that my horizontal shift isn't going to be there. And the last thing I've got to look at is what's the period of the function. So the standard sine curve has a period of 2 pi. And in this case, we can see that it takes from here out to here to get back to my starting point, right? So one full cycle takes me 2 pi units. So that means that here, the period is equal to 2 pi. So we don't have any horizontal stretch. So I've got the normal period is 2 pi, and I've got this one is 2 pi, and so that equals 1. So we don't have to do anything complicated there. So that means that this blue function is quite easy to write. It's going to be this. Y is equal to 3 sine x, and that's it. I've got no horizontal shift. Oops. Sorry. And I've got no horizontal stretch, and I've got no horizontal shift. Right? So again, the basic form is this. Y is equal to A sine B x plus C plus D. A is the amplitude. D is the vertical shift. B is the horizontal stretch. So that's related to what we call the frequency. Right? How many cycles there are inside 2 pi. And then C is the horizontal shift. And in this case, that collapsed down to a very simple equation. Let's have a look now at the red one. Well, we can see with the red one that we've definitely got some vertical shifting happening. So we'll start by looking for the vertical shift and for the amplitude. Right, well, this function goes from 1 here to 5 here. So we've got the midline is at 1 plus 5 divided by 2, halfway between those two values, which is 3. So if you want to, you can take your ruler and you can plonk that in on your graph. There we go. Sometimes that can help us see what to do. Let's take off all the other mess. Okay, so my vertical shift is going to be 3. Now let's look at the amplitude. The amplitude in here goes from 3 up to 5. So the amplitude is 2, and the vertical shift is 3. What else have we got? Well, we don't have a horizontal shift. We're using a sine curve. My starting point is right here, so that's very nice. And we can see again that one full cycle is going to take me from 0 to 2 pi units. So the period here is just 2 pi. So I don't have any horizontal stretch going on. So the equation for the red curve will be y is equal to 2 sine x plus 3. Okay, I've got a vertical shift of 3 and my amplitude is 2 instead of the standard 1. Right, let's look at the next two graphs now. Okay, well, they're kind of hard to see here, but let's look first of all at the red one. Well, you can see that the red one has a little bit going on. It's definitely been kind of sped up, so that means that the period is now smaller than 2 pi. But we're not going to start there. We'll start with looking for the vertical shift, and then we'll start with the amplitude. So the highest value here is at 5, and the lowest value here is at -3. So we want to find the halfway point between those two. So we do that by saying 5 plus -3 is going to give me that number. And that will be 1. What's the other way I can do that if my brain is freezing over? Well, I can see here I've got a gap of 8. So I need to come down halfway through, and that's where that 1 comes from. So let's put in our midline. We can put our ruler on. Here it is here, and sometimes that will help me see things. Okay, so the midline's on. We've got the vertical shift. Now we're going to get the amplitude. Well, you can see that the amplitude is going to be half of that total distance, so the amplitude will be 4. Have I got a horizontal shift? Well, again, we haven't got a horizontal shift. We can see that we can start our sine curve off right here at x equals 0. But we have got a horizontal stretch because one full cycle of this is only going to take me pi units. So let's see where we're at. We've got A is 4. D, the vertical shift is 1. And now we've got to work out what the horizontal stretch is. Well, the normal period is 2 pi, but my period here is only 2. So I'm squishing everything up by a factor of 2. And happily, I've got no horizontal stretch. So that means my equation is y is equal to 4 sine 2x instead of x plus 1. So that's the red one done. All right, we'll get rid of that. Now let's look at the blue one. Well, the blue one looks easier, and it is, but it's been shoved down. So there's definitely some vertical shift going on. And we'll just get rid of this and start working on this. So now you should be familiar with what we're going to do first. We're going to look for what I call the midline to get the vertical shift. So this one goes from 0 down to -4. So the halfway mark there is -2. Let's get our ruler, put in our line halfway through here. Right, that means I've got a vertical shift of -2, and you can see I've got an amplitude of 2. Now, in this one, you have to be really careful because we have got a horizontal shift. And it's a bit hard to see because we've got the red line sitting in there mucking everything up. But look at where the starting point is for the sine curve. We need to have our sine curve starting point is this point here where we're about to start going up, right? And that's not what I've got here. So I've got a horizontal shift, and I can think of it either as being shifted back to here, or I can think of it as being shifted out to here. It doesn't make any difference. But I'm going to think of this as having a starting point of the sine curve there. So what does that mean? Well, my C term this time is going to be plus pi, right? I'm shifting pi units left. I have to ask if I've also got a horizontal stretch. Now, happily, I don't. You can see that one full cycle is still taking from -pi out to pi. So that means that this equation is going to be y is equal to 2 sine, and then it's going to be x plus pi minus 2. Right, this minus 2 is the vertical shift, this 2 is the amplitude change, and this is my horizontal shift. I've just got time to do the last couple, I think. So let's look at these. Okay, I'm going to do these a little bit faster. So this one here has got no horizontal shift. It's going to 5 here and 1 here. So this midline is at 3. The amplitude is going to be 2. And we've got a really kind of stretched out curve. So one period of the cycle is from here at -3 pi going to pi. So the period here is 4 pi. So that means that my horizontal stretch is going to be the normal period over this one, which is 1/2. So y is equal to 2 sine half x plus 3. Right, 1 minute to do the next curve. I'm going to choose a sine curve again. I've got no horizontal shift because I'm starting here. This one is going to, oh yuck, this is going to 1.5 here and -3.5 here. And I don't think I'm going to get this one done in 30 seconds, but let's see what we've got. Well, this range here is 5. My halfway point will be at -1. So it's going to be y equals, let's see, 2.5 sine, trying to see how long the period of this function is. You know what? I'm going to do a separate video for this blue one because I don't want to muck this up and rush it. So thanks for watching for 14 minutes. I hope that wasn't too slow. If it was, maybe you put it onto double speed or something like that. I'll be back soon with some more trig graphs.